Hello viewers, welcome to part 1 of the video series on basic definition and relationships related to soil mechanics. In this video, we'll be looking after the fundamental definitions related to soil, as this definition, or we can say the properties of soil, are very much helpful for an engineer to classify the soil as well as to predict the engineering behavior of the soil. So the first definition is the moisture content. Moisture content is defined as the ratio of mass of water to the mass of solid. It is denoted by small w and it is expressed in percentage. Technically, moisture content denotes the water holding capacity of the soil. The next is the void ratio. It is defined as the ratio of volume of voids to the volume of solids. Void ratio is usually larger for coarse grained soil, and for fine grained soils the void ratio value is smaller. It is denoted by small e. Third is the porosity, which is defined as the ratio of volume of voids to the total volume. It is denoted by small n. Porosity is largely used by the engineer and as well as the agriculturist for preparing their reports. The fourth definition, is the degree of saturation, which is defined as the ratio of volume of water to the volume of voids. This degree of saturation is denoted by capital S and it is also expressed in percentage. In case of fully saturated soil, which is completely filled with water, means there is no air, so volume of water is equal to volume of voids, and hence we write the value of S as 1. And in case of fully dry soils, when the voids are completely filled with air, means there is no water, volume of water is 0, we can say, and hence in that situation the value of S, that is degree of saturation, is considered as 0. Fifth is the air content, which is defined as the ratio of volume of air to the volume of voids. It is denoted by AC. The next fundamental definition is the percentage air content. Percentage air content is basically defined as the ratio of volume of air to the total volume. It is denoted by Na, and like degree of saturation and the water content, it is also expressed in percentage. Then comes the density. So basically density is the ratio of total mass of the soil to the total volume of the soil. It is denoted by rho, and it is also referred as bulk density or mass density. So if someone says what is the difference between bulk density and density, they both are same thing. Next is the unit weight. So basically it is similar to the density, but instead of mass we have to consider the weight of the soil. So the ratio of the weight of the soil to the total volume of the soil is the unit weight. It is denoted by gamma, and it is also sometimes referred as bulk unit weight or weight density. The next definition is the dry density. So dry density is defined as the ratio of mass of soil solids to the total volume of the soil. It is denoted by rho d. Similarly, dry unit weight is defined as the ratio of weight of the soil solids to the total volume of the soil. It is denoted by gamma d. So in all the definitions of density and the unit weight, the difference is at the numerator, where the mass is replaced by the weight. Then comes the density of solids. The density of the solids is defined as the ratio of mass of soil solids to the volume of soil solids. It is denoted by rho S. Then next is the unit weight of solids, which is again the ratio of the weight of the soil solids to the volume of the soil solids. It is denoted by rho S. Next is the saturated density. So saturated density can be defined as the ratio of weight, or you can say the saturated mass of the soil to the total volume. It is denoted by rho set or gamma set in case of unit weight. This saturated density is very much helpful in to find the submerged unit weight or submerged density of the soil mass. So the next definition is the submerged unit weight. Submerged unit weight is basically the effective mass per unit volume when the soil is submerged below the standard water or below the groundwater table. It is denoted by rho dash, and it is equal to rho set minus rho W. Then next definition is the specific gravity. So specific gravity in case of soil can be defined as the ratio of volume of the soil solids to the weight of an equal volume of distilled water. If we write it down mathematically, specific gravity, which is denoted by capital G, can be written as rho S upon rho W or gamma S upon gamma W. The next definition is the mass specific gravity. So the specific gravity of mass of soil, that is including air, water and solid, is termed as the mass specific gravity or the bulk specific gravity. It is represented by Gm and it is expressed as rho upon rho W or gamma upon gamma W. The next definition is the relative density. Basically, relative density is the measure of the compactness of the cohesionless soil. Relative density or the density index is the ratio of difference between the void ratios of cohesionless soil in loosest and natural state to the difference in its void ratio in the loosest and the densest state. So that's all from this video. If you have liked the video, hit the like button, share it with your friends and subscribe to our YouTube channel for more such videos related to civil engineering. Thank you.